It's not a game, it's a rich thing.
The Sun has 8 billion years left. Earth has even less. As per data reveals by ESA, the Sun is not going to last forever. Scientists are able to predict what will be the future of the star that provides energy to our solar system. However, we will not live to see it. ESA's star mapping GAIA mission now gives us a look at the future of the Sun by identifying stars of similar mass and composition and predicting how our Sun is going to evolve in the future. Although the Earth has less time than the Sun, let's find out what will happen in the future. We already know that nuclear fusion powers the Sun. The Sun will continue to get hotter and hotter over the next few billion years, and eventually the hydrogen at its core will be depleted. The core would then contract to bring the hydrogen to form the nucleus. While the core is busy shrinking, the Sun's outer atmosphere will begin to expand significantly. It eats away at Earth and even engulfs Mars, making the Sun a red giant. As the Sun's core eventually runs out of hydrogen and helium, it will eject all of its outer material to form a planetary nebula. Meanwhile, the core will collapse into a white dwarf. While this is based on how other stars have evolved over time, it is important for Earth residents to at least have an idea about the future of our planet and the Sun. The third and latest data released, ER3, from ESA's GAIA mission, shares some insights on the timeline of the Sun's life. One of the major products that came out of this release was a database of the intrinsic properties of millions of stars. These parameters include how hot they are, how massive they are, and how much mass they contain. What the GAIA mission does is to take accurate readings of the star's apparent brightness and color from Earth and plot it on a single diagram known as the Hertzsprung-Russell (HR) diagram. An HR diagram depicts the intrinsic brightness of a star against its effective surface temperature. By doing so, it reveals how stars evolve over their long life cycles. While the mass of a star changes very little during its lifetime, mass changes in temperature and size as the star ages, driven by the types of nuclear fusion reactions that occur in the core. At the age of 4.57 billion years, our Sun is in its middle age and stationary state. However, as the Sun ages, this stability will change. That's where the GAIA mission's latest data, ER3, comes in. Or La Crivie, Observatoire de la CTE des France, and colleagues from GAIA's Coordination Unit 8 combed the data in search of the most accurate stellar observations the spacecraft could offer. They focused their efforts on stars whose surface temperature is between 3000 kelvins and 10,000 kelvins because they are roughly similar to the Sun, which has a surface temperature of 6000 kelvins. Additionally, these are the longest-lived stars in the Milky Way and therefore can reveal the history of the Milky Way. They are also promising candidates for finding exoplanets. The team then filtered the results to show only those stars whose mass and chemical composition were similar to those of the Sun. Since they allowed ages to vary, the stars they chose traced a line in the HR diagram that represents our Sun's evolution from its past to its future. This suggests that as we age, the Sun changes its temperature and brightness. The results suggest that our Sun will reach a maximum temperature at about 8 billion years of age, then it will cool down and increase in size, becoming a red giant star around 10 to 11 billion years old. After this stage, the Sun will reach the end of its life when it will eventually become a dim white dwarf. How long is Earth near? While it is 8 billion years ahead of the Sun, Earth has a much shorter period of time at 1 billion year. This is because the Sun's brightness and temperature are increasing by 10% every billion years, while 10% seems negligible. It would heat Earth enough that the planet would become habitable for any form of life. Orlag and his colleagues looked for stars with temperature, surface gravity, composition, mass and radius that are all similar to the present-day Sun. He got 5,863 stars which matched his criteria. It also brings a ray of hope to life as we know it, as there is always the possibility of finding habitable planets like Earth among these 5,863 stars like our Sun. At the moment, we don't know if there is a planet that could harbor life. But the search is on.